Assalamualaikum and welcome to the second lesson of week 2. In the last lesson, we learned about statistics and saw that it can be divided into two main branches, of which descriptive statistics is the first one, and it is also the one that we'll be studying for the first half of our course. And today is the first lesson on descriptive statistics, in which we'll study about the measures of central tendency. But before we try to learn what these measures are, let's first recall our understanding of descriptive statistics itself, which we know are a set of statistical techniques that are used to summarize and describe the main features of a data set in a quantitative manner. Now, I highlighted that in the last lesson also, and I'll do that again, that irrespective of the type your data was originally recorded in, which may or may not be numeric, such as if you're conducting some sort of a survey and you're recording the demographics of respondents, it may include numeric values such as their ages, their number of dependents they have, number of years of experience, and so on. And it may also include values which are not numeric, which are non-numeric in nature, जैसे कि उनकी qualifications, उनकी designations, उनकी food preferences, उनकी color choices, and so on. Irrespective of the type, the data was originally recorded in the descriptions or summaries, or in other words, the descriptive statistics, they strictly deal with numbers. And these include three different kinds of measures, which are measures of central tendency, of dispersion, and data distribution. We're going to have a look at each one of them, but in today's lesson, we'll be discussing about the measures of central tendency study. So with this term, central tendency, it already gives us an idea that it has something to do with the center. And since we established in the last lesson that in statistics, it's all about numeric data and large numbers of numeric data or data sets, huge data sets of numeric values. So it has, we can make this connection already that it has something to do with the center of these data sets. But before we proceed, please note that this center does not necessarily always mean the midpoint. Although in some cases, it actually will be the midpoint, but not always. So by this term, center or central tendency, it means to actually identify one single value as a representative of the entire data set, irrespective of how many different values there are in the data set and how many of them are there in the data set. We identify one value as a representative or as the most as the central value of the data set. And once you do that, you can locate your data set on the number line. That is why they're also known as the measures of location of data. And after that, you can compare two data sets. So we can explain that with the help of a simple graphic. If I draw this number line here, और अगर मुझे ये पता हो कि there are two data set, one is D1, and the central value for D1 is located at this point, which is say 27. And there's another data set, which is D2. Irrespective of how many values are there in D2 and D1, if I know that D2 has a central value, again, we do not know at this point how we calculate that central value. But if someone tells us that इसकी जो central value है, वो है 67 in magnitude, और जब आपने number line पे draw किया, तो of course वो यहाँ पर है. So now, by just having this small piece of information from these two data sets, which is just one value about these two data sets, we know that the values in dataset D1, typically, generally, the values in dataset D1 are smaller as compared to the values in dataset D2. Of course, the exact values that are there in the dataset will be different, they're varied. And if we compare individual values with each other, we can have different comparisons, different outcomes. But generally speaking, but this information you can conclude that the values in dataset D1 are smaller than the values in dataset D2. So such kind of comparisons, such kind of decisions or conclusions can be made by if you know the central values of datasets. So what it means is to basically give an idea of the center or the typical value of the data set, or in other words, that gives you an idea of what to expect, what values you expect to be there in the data set. Okay, so we can see that with the help of examples. Says, for example, if someone tells you that the typical age of a new entrant in BSSC program at your university is 19 years, so that is an idea of the central value, which means कि अब आपको पता है कि अगर यानी इस ग्रुप के जितने भी स्टूडेंट्स हैं जो कि ये न्यू एंट्रेंट्स हैं टू दिस प्रोग्राम एट दिस यूनिवर्सिटी, उनकी एजेस दे आर 19 और वेरी क्लोज टू दैट. Of course, exact ages they are going to be different. Not every student is exactly 19 years. कुछ बड़े हैं, कुछ छोटे हैं, but they are typically that age or very close to that. So this is the idea of the central location. Again, example could be the average price of a house in a certain area. If it is said to be 60 million, तो you can make your decision कि अच्छा इस एरिया में अगर ये generally values ऐसी हैं, तो डिपेंडिंग अपॉन द बजट दैट आई हैव, क्या मैं यहाँ पर घर अफोर्ड कर सकती हूँ या नहीं. कोर्स एग्जैक्टली इंडिविजुअल हाउसेस, हर अलग घर की प्राइस डिफरेंट होगी, बट दैट्स अ जनरल आइडिया ऑफ व्हाट काइंड ऑफ प्राइसेस आर देयर in that area. Then if someone tells you, or if you know that by your experience that your friend usually reaches university after 8:30 in the morning, so you know that there's no point in planning a meeting with her or him before this time, because that can result into disappointment, क्योंकि वो अगर उसका usual time that है, तो this is basically an idea of a measure of the central tendency, or a central value about the reaching time of your friend to the university. ठीक है, so इस किस्म की values से आप क्या कर सकते हैं, आप अपने small decisions जो है, you can base your fundamental decisions can be reached at based on these values. ठीक है, अब इसके लिए जो खास तौर पे measures इस्तेमाल होती हैं, जो हम उनको फॉर्मली डिफाइन करेंगे और कैसे कैलकुलेट करते हैं, तो दैट वी आर गोइंग टू सी नाउ. These are a mean, which we are already familiar with, not exactly by this name. Maybe you know it as average, which we have been calculating since our class 2, but it is something which is there, which has been there all the time. शायद इस नाम से हमें ना पता हो, although ये नाम भी काफी popular है, but we have been doing it all our lives. ठीक है, दूसरा मीडियन है और फिर मॉड है. और मीन सबसे ज्यादा फ्रीक्वेंटली इस्तेमाल होने वाला है, और मीडियन और मॉड भी जब रिपोर्ट करते हैं हम स्टेटिस्टिक्स में सेंट्रल टेंडेंसी को, तो जनरली वी रिपोर्ट ऑल ऑफ दीज वैल्यूज. नाउ वी आर गोइंग टू सी व्हाट हाउ एक्चुअली वी कैन कैलकुलेट दीज वैल्यूज. अच्छा, इधर आपको मीन के साथ नजर आ रहे हैं दो सिंबल्स, एक है एक्स, उसके ऊपर बार डली है, एंड वी प्रोनाउंस इट एज दैट एक्स बार, एंड द अदर वन इज म्यू. तो अगर आपको याद हो, in the last lesson we defined two terms. One was statistics and the other was parameter. Statistic was a numerical quantity associated to a sample, which is a small subset from the population, and parameter is a numeric quantity associated to the population. तो यहाँ पर भी x bar is the sample mean, which we calculate from a sample, and mu is the population mean, which we calculate using all the values in your population. तो x bar is statistics and mu is parameter. अच्छा, अब mean क्या है? It's just an arithmetic average, again, which we have been doing all our lives by just adding up all the values and dividing them by the count, by the total numbers of values that we added. As simple as this. ये formula यहाँ पे लिखा हुआ नजर आ रहा है, x bar is equal to summation of xi's, all the values in your data set, divided by the total count. And let's see that in action with the help of an example. If we have the marks of 15 students scored out of 20 given here, so mean is calculated by calculating the sum of all of these values, which comes out to be 218. You can verify that, or dividing it by 15, which gives us 14.533 as the mean of this data set. अच्छा जी, अब इंटरप्रिटेशन इसकी क्या बनेगी? A typical student of this class would have marks around 14.533 in this quiz. ठीक है, तो generally you would expect कि अच्छा जी, an average student from this class is going to have marks which are very close to 14.533. And when I say close to 14.533, it is because of the point that you should note here, which is that the mean value that you calculate is not necessarily an exact point in your data sets. So you see here 14.533 is the mean of this data set. लेकिन अगर आप data set में जाके देखोगे तो you do not find a value, this value as a data point in your data set. So mean is a representative value, represent or typical or central value of your data set, but it is not necessarily a point, an actual point in your data set. So that is the reason कि आपकी value जब हम mean की बात करते हैं तो we know that the values in the data set, they're very close, they're spread around this central value, they're very close, very similar to this value, although of course there are going to be different values which are very different, which are known as outliers, and we are going to discuss about that in a while. Acha ji, let's discuss another example. If the number of bugs reported in 15 modules of a software are given, यहाँ पे आप देख सकते हो, and again you can see very different values. And if you're required to calculate the mean or the average number of bugs in a module of this software, you do that by adding all of those values up, which is 66, and then divided by 15, and you get 4.4 bugs, number of bugs. Okay, so this is the average number of bugs a module of this software still has. Okay, Ji. So the next one is median. Acha, median is actually the center point, is in terms that is the midpoint of the data. It's the mid that we calculate from our data. And these are the generally the notations that you would see. All those, usually you are going to see this whole term median written for median, but sometimes it is written as ME, and other times it's also written as this is for the population and this is for the sample. So you can you might see it written as this with a tilde sign on the X. So this is the idea of mean. Now it's important to understand what it means. When we say it's the midpoint, it actually is that it is one value in your data set, which may or may not be an exact value in your data set, but this one value which divides your data set into two equal halves in terms of the number of values which are greater than it and the number of values which are smaller than it. ठीक है, तो आसान अल्फाज में क्या है, एक ऐसी वैल्यू जिससे नीचे, जिससे छोटी वैल्यूज की जो काउंट है आपके डेटा सेट में, इट इज द सेम एज द काउंट ऑफ वैल्यूज विच आर अबव दिस वैल्यू, जिससे बड़ी वैल्यूज की है. ठीक है, सो बाय इक्वल हाफ से मतलब इन टर्म्स ऑफ काउंट है, तो जो वैल्यूज इससे छोटी हैं उनकी कुछ काउंट और जो वैल्यूज इससे बड़ी हैं उनकी काउंट, इट इज द सेम. सो दिस इज द वैल्यू व्हिच डिवाइड्स योर डेटा सेट इनटू टू इक्वल हाफ्स. हाउ डू वी कैलकुलेट दैट? आपको अब सिंस इट डील्स विद द काउंट ऑफ वैल्यूज जो कि बड़ी है छोटी हैं, तो हम पोजिशंस के ऊपर बात करेंगे. सो इफ यू इट इज एक्चुअली जो मीडियन वैल्यू है ना, इट इज एक्चुअली अ वैल्यू इन द डेटा सेट occurring at the mid position, which is, how do we calculate the mid position? We calculate it by this expression, which is n plus 1 divided by 2. तो अगर n number of values हैं आपके डेटा सेट के अंदर, 10 भी हो सकती हैं, 11 भी हो सकती हैं, तो आपने इस एक्सप्रेशन से उसका मिड पॉइंट निकालना है. ठीक है, और उस पॉइंट के ऊपर जो भी वैल्यू एग्जिस्ट कर रही है, दैट इज योर मीडियन ऑफ योर डेटा सेट. ठीक है, अच्छा, इसमें अब एक बड़ा इंपॉर्टेंट पॉइंट है जो कि यूजुअली टिपिकली स्टूडेंट्स मेक दिस मिस्टेक व्हेन they are doing it by hand, although of course there are tools available for it, but if you're doing it by hand, so typically this mistake that students make is that they do not अरेंज द डेटा. हम बात करें ना बड़ी और छोटी वैल्यूज की, तो जब आप डेटा सेट को हाफ में डिवाइड करेंगे और बड़ी और छोटी वैल्यूज निकाल रहे हैं, सो दैट actually needs that you arrange your data set first before you calculate the midpoint, before you calculate the central value. You need to arrange your data set, you organize your data set in either ascending or descending. It is irrespective of that, कोई भी आप कर लें, but it has to be organized in either ascending or descending order before you actually find out the mid value. ठीक है, पोजीशन तो आप निकाल ही लेंगे, वो उसके लिए आपको सिर्फ टोटल नंबर ऑफ वैल्यूज चाहिए. तो अगर आपके पास 10 वैल्यूज इन योर डेटा सेट, इट मींस कि आपके पास ओरिजिनली डेटा सेट के अंदर इवन नंबर ऑफ वैल्यूज हैं, तो आप ऑलरेडी देख सकते हैं कि दिस एक्सप्रेशन इज गोइंग टू गिव यू ए नॉन इंटीजर वैल्यू. ठीक है, 10 plus 1 is 11, 11 by 2 is 5.5. 5.5 is not an integer value, it's not a position. आपको पता है कि डेटा सेट में positions जो values की हैं 1 2 3 4 वो discrete locations हैं, those are not fractional values. लेकिन अगर आपके पास originally odd number of values हैं तो then it is going to give you an integer value. अब इन दोनों केसेस में जो मीडियन की कैलकुलेशन है वो कैसे होगी वो हम यहाँ पर देख लेते हैं. अगर तो आपके पास ऑड काउंट है, n की वैल्यू ऑड थी डेटा सेट में, तो यू आर गोइंग टू गेट द पोजिशन ऑफ द मिड एज एन इंटीजर. मिड वैल्यू इंटीजर आएगी और उस पोजीशन के ऊपर जो भी वैल्यू पड़ी होगी डेटा सेट में यू आर गोइंग टू टेक इट एज योर मीडियन. लेकिन अगर आपके डेटा सेट में और इवन नंबर ऑफ वैल्यूज थी तो ये जो एक्सप्रेशन है मिड पॉइंट की कैलकुलेशन n+1 डिवाइडेड बाय 2 इज गोइंग टू गिव यू ए फ्रैक्शनल वैल्यू. और वो जनरली फ्रैक्शन क्या होगी, एनी वैल्यू उसके आगे 0.5 लगा होगा. सो इन दैट केस वी आर गोइंग टू पिक टू वैल्यूज. वन say if it is 5.5, so you're going to pick fifth value at the fifth position and the value at the sixth position and take average of that as the mean of this value. Let's see that with the help of an example. Interpretation पे बाद में आते हैं. So it's the same data set of marks of 15 students in a quiz. इसकी मीडियन अब कैसे होगी? अगेन डू नॉट फॉरगेट टू arrange your data first before calculating the mean. ये सबसे बड़ी गलती स्टूडेंट्स जो करते होते हैं हमेशा when calculating by hand. तो आपने ऑर्गेनाइज करना है डेटा सेट को किसी ऑर्डर के अंदर, असेंडिंग या डिसेंडिंग. नॉर्मली असेंडिंग इस्तेमाल होता है तो हम यहाँ पे असेंडिंग में कर रहे हैं. After arranging the data set in ascending order, we get this arrangement. Ab, we know that these are 15, so the count is odd. When we apply this midpoint calculation expression, we get 15 plus 1 is 16. 16 divided by 2 is 8. So we will have to calculate, find out the 8th position and the value at the 8th position. So 1, 2, 3, 4, 5, 6, 7 and 8. Okay. 15 is जो वैल्यू है वो 8th पोजीशन पे पड़ी है. So this is going to be the median of our data set. ठीक है. लेकिन अब अगर दूसरा केस हो, इफ यू हैव इवन नंबर ऑफ वैल्यूज इन योर डेटा सेट, जैसे कि नीचे है तो ये ऑलरेडी अरेंज्ड लिखा हुआ है असेंडिंग ऑर्डर में और वी एडेड जस्ट वन वैल्यू टू इट. सो नाउ वी हैव इंस्टेड ऑफ 15 वी हैव 16 नंबर ऑफ वैल्यूज इन इट. सो फॉर काउंट 16 द मिड विल बिकम 16 plus 1 is 17. 17 divided by 2 is 8.5. Now there is no such position 8.5. So what do we do for the 8.5th position? We're going to take the values, two values, which is one at the 8th position, the other one at the 9th position. So we have the one at 8th position is 15, the one at 9th position is 16, and we find the something between them, which is the average of that. So we add these two values up. 15 plus 16 is 31. 31 divided by 2 is 15.5. And the median of this data set below, जो अभी हमने 16 values के data set लिए, इसकी median 15.5 है. Now again, please note that in case when you had odd number of values in your data set, the median was one value from the data set. So it was an original data point in your data set. But in case when the number of values or the count of values in your data set was even, the median value is not an original data point in your data set, which was the case for mean as well. So 15.5 is not an actual data value in your data set, but it's the median of your data. Now coming to the interpretation, this tells us in the first case here, जहाँ पर हमारे पास 15 median आई थी, so that means that half of the students in this class have numbers, scores, which are below this value 15. And the other half have values, scores, which are above 15. So this is the interpretation of median. Okay, let's again, this should be emphasized that whenever you're calculating it, the median, always remember to arrange your data first in ascending or descending order. There's another example here. If we are given to the training time of a machine learning model in nanoseconds on 12 different CPUs as this, these are 12 different values. What is the median training time for this model? So what do we need to do first? The first thing is, for median calculation, we need to arrange the data. We need to sort it in any of the orders. We sorted here it in the ascending order and we got this arrangement. And now, what's the count? It is 12. We know that 12 is even. And we should also already know that when it is even, we're going to get a fractional value as the midpoint. So 12 plus 1, the expression tells us n is 12. 12 plus 1 divided by 2 gives us 13 by 2 is 6.5th position. So that means we will have to identify two values and take their mean. So 6.5th means sixth value, sixth position, and the seventh position. So starting from here, we have 1, 2, 3, 4, 5, 6th, which is 56, and seventh position, which is 60. So the median is the average of the entries or values at sixth and seventh position, and we calculate them as the average of these two numbers, which is 56 plus 60 divided by 2 as 58. So 58 is the average, or the median of this data set. Okay, it's the median value. The median training time for this model is 58 nanosecond. Okay, the last one, last measure of the central tendency, which is the easiest to calculate. Actually, there's no calculation involved here. It's just that you have to see which value is occurring the most in your data set. So for that, you just need to scan the values there in your data set and find out the one which is repeating the most or which has the highest frequency. Again, we have the same data set of 15 marks, and all we need to do is to find out the value which is occurring most frequently. Here, the mode is 18. How? You can just count the occurrences. 10 appeared once, 18 appeared twice, 19 appeared twice, 17 twice, 9 once, and so on. So you count the occurrence of these, each of these values, and the one with the highest occurrence is the mode of your data. So here it is 18. Now, interpretation of this is a typical student from this class is more likely to have scored 18 marks than any other value because this is the most frequently occurring value, it's the most repeating value. So the probability of, if you just randomly pick marks, the probability of getting 18 is highest of all of getting any other value. So this is the interpretation of mode. And you also need to note here that your data can be multi-model, which means that you can have more than one modes. जैसे कि इस केस में यहाँ पे देखें 2 is being repeated thrice, 3 times. 4 is repeated just once. 7 appears twice. 5 appears 3 times. And 6 appears twice. And so 1 also appears 3 times. So basically, we have 3 modes of this data set, which is 1, 2, and 5. So you can have such cases also. There's another example, marks of 20 students in a programming quiz. This is what's given. How do you calculate the mode of this data? The easiest one would be to create a frequency table. It is that you just list down all the unique values that you have. ये 1 2 3 4 5 जितनी भी values आ रही हैं वो एक साइड पे लिख दी, and then you write their frequency. So 1 appeared once, we wrote once. 2 twice, 3 appeared twice, we wrote 2, 4 appeared twice, and so on. And after listing all the frequencies of each of these values, we got to know that 9 appeared the most. It's repeated the most. So times it is 4. So the mode of this data set is 9. Okay, so now we know the measures, 3 different measures that are used to find the central value or central tendency of a data set. It's time that we compare those also. In which situation should we use which, and what are the limitations of each? Although when someone's reporting the measures of central tendency, usually they report all of these 3 measures, but there are cases where some of them are preferred, one is preferred over the other, and so. Acha, it is important to note that mean, although it's the most popular one for the central tendency, it is sensitive to outliers or the extreme values. Now, by outliers, we mean values which are very different from the typical value. ठीक है, जैसे कि 19 years हमने कहा कि एंट्रेंट्स की जो आपके न्यू एंट्रेंट्स है BSSC स्टूडेंट्स, उनकी 19 years एज है, लेकिन से 13 years का भी कोई आ जाए. So it's a very rare value and it's very different from 19. ठीक है, तो mean is sensitive to outliers. और उसके लिए एग्जाम्पल यहाँ से देख सकते हैं। अब ये एक छोटा सा डेटा सेट लिखा हुआ है 22453 इसकी मीन कैलकुलेट की है तो इट इज 2.833 x bar is 2.833 and then we have the uh, we add one value which is 20 and now it's an outlier. It's very different from the other values in the data set. So it's an extreme value or it's an outlying value. We added that. We added just one value to the data set and see how the mean changed. Now the mean of the same data set with the addition of just one value, but that was an extreme value, is now 5.285. Meaning it jumped by 3 values, by 3 points. Median is robust to extreme values. How? We have the same data set. We have 224,531, the same data set. The median came out to be 2.5 for this. And now we added the same extreme value to this data set, which is 20. And the median only shifted by 0.5. The median now in this new case is 3, only 3, just a difference of 0.5. So it is relatively more robust to the addition of outliers. While in case of MOD, it is quite robust. It's even better. It responds even better as compared to median to the addition of outliers. And we see that here. We have the same data set. We add the same extreme value to it, but the mode does not change. Why? Because it is the most frequently occurring value. And also note that mod is the value which is occurring most frequently. It's repeating for most of the times in your data set. So an extreme value, on the other hand, or an outlier is very rare. So if you add an outlier, it means that you're adding a value which is very rare. So it's not going to change the mode of your data. So that is why mode is robust to the addition of outliers, but mean is not. Median is somewhat, although there are some changes, but it is quite, as compared to mean, it's quite stable, even if you add outliers to it. Mod के केस में अगर आप बहुत बड़ा outlier भी डाल रहे हैं ना, मतलब 20 की जगह 200 भी add होता, तो mod wouldn't have changed in this case. So, but we report all 3 of them. अच्छा जी, there is the, okay, so the comparison continues here. अब मीन्स जो है दे विल वर्क विद इवनली डिस्ट्रीब्यूटेड डेटा सेट्स जिसके अंदर आउटलायर्स नहीं है, ठीक है, वो हमने देख लिया व्हाई, बिकॉज an addition of just one outlier affects the value of mean. At the same time, there's another fact that you should know. It's only that you need to be conscious of this when you are calculating these values. The second point, which is mean value, may not be an actual data point in the data set. We've seen that. We've established that already. Although it does not make a difference, it's only that you need to be aware of this. So as we calculated in our first example, 14.533 as the mean of the scores of 15 students in a quiz, this 14.33 was not an actual data point in your data set. And same is the case for median also, in case when you have even number of values in your data set, because the median calculated in those cases are not an actual data point in your data set. But for odd values, those are picked from your data set. Medians are better with outliers. We have seen that. So if your data set is skewed, which means it has more number of values of higher or lower magnitude, which are skewed data sets, in that case, and if they have outliers, medians work better. They're better representative of the central values as compared to means. And mode are even better in case of outliers. But there's another thing. There's if you have a certain kind of data set which is discrete in nature, which is not continuous, and discrete values may be resulted because of the result actually because of numeric encoding of data set. For example, let's consider this with the help of an example. We have a data set of in which people were reported their favorite colors. Now, this data set has values which are non-numeric. You can convert them to numeric values. That is okay. You can give codes to the colors. Now, when you give codes to these colors, it will be converted into numeric. You can say red is 1 or blue is blue for 2 and all. You can give color codes to these values. Now, when you give color codes to these values, they will have these numbers. If you try to calculate the mean of these numbers, it is going to be some value. You can always, but theoretically, you can calculate the mean of this. But if the mean comes out to be 2.5, that does not make any sense. It doesn't represent any color. 2 is blue, 3 is probably yellow, but 2.5 is nothing, because someone who said 2 meant blue, someone who said 3 meant yellow, but 2.5 is nothing. It does not make sense to have it as a mixture of blue and yellow in this case. So mean doesn't apply here. Similarly, median does not apply. Why does it not apply? Because median needs to have data which has some sense of ranking or order in it. That is why we always need to sort our data before we can calculate the mean. So even if your data was qualitative, even if your data was non-numeric, but it was ordinal, it had ranking, median still applies. For example, if it is the hierarchy of designations at some place, lecturer, senior lecturer, assistant professors, associate professors, and full professors. So here we have this sense of ranks or ordinal data. The median can be calculated as the midpoint of that, which is lecturers, senior lecturers, and assistant professors. So assistant professor is the mid, and there are 2 ranks below this. There are 2 ranks above it. So the concept of median applies to that. But in case of the example that we've been discussing previously, which is of colors, the median does not apply, because colors are not ranked. The colors, they're all the same. There's no ranking or ordinality between the colors. So in this case, the only measure of central tendency could be the mod, or the most frequently occurring value. So if you have a collection of all the preferences of, say, 50 employees who gave their color choices, so the measure of central tendency in this case would only be the mode of it, which is the highest, the most frequent color that was reported. For example, if it is red, it's going to be red. But you cannot calculate mean. Mean does not make any sense. Calculation is not a problem. Mean doesn't make any sense. Median doesn't apply. So the only option is mode. So the takeaway from this discussion is that means can be calculated for numeric values, which are actually originally numeric, which mean numeric quantities. Median need ordinality. So with the originally numeric values, it works well because it has the magnitude is the order. But for the qualitative data, it can still work if it is ordinal. But if it is nominal data, if it's not even ordinal, then only a measure of central tendency that you can work with is mod. But there's another characteristic of mod is that mods may not be useful in data sets which has no repeating value. So there can be data sets where the values, they do not repeat. They're unique values. So in that case, mods do not make sense because none of the values is repeating. Okay, so after discussing all of this, we can summarize and also see why we need the measure of central tendency. तो आसान सी अभी तक हमें इतनी समझ तो आ चुकी है कि इस central tendency की measure से हम करते क्या है. Basically तो हमने decisions लेने होते हैं, fundamental decisions हम ले सकते हैं कुछ situation के बारे में. लेकिन ये हमें क्या बताती हैं? They can summarize large data set as one single value. तो अगर आपके 50 values भी थी data set में और ज़्यादातर तो उससे ज़्यादा ही होती हैं, you only need to memorize just one value to make fundamental decisions. It provides a quick overview of what's typical or what to expect. तो आपको अगर पता है कि typical age of students who are entering to this program is 19 years, तो आपको पता है कि हर नया आने वाला student जो है वो 19 years का ही होगा या उसके करीब करीब होगा. तो अगर आपने उसके accordingly कोई interventions करनी है तो you can do that. Allow for quick comparison between data sets जो अभी हमने देख लिया है. डेटा सेट्स की सेंट्रल वैल्यूज को आप कंपेयर करके अंदाजा लगा सकते हैं कि कौन सा डेटा सेट में किस किस्म की हाई वैल्यूज है या लोअर वैल्यूज है या सिमिलर थिंग्स. और फाइनली इन तमाम चीज़ों से हमें फ़ायदा क्या होता है कि वी कैन मेक फंडामेंटल डिसीजन. सो बेसिक डिसीजन मेकिंग है वो हम कर सकते हैं. Now, after having said all of this, there are certain limitations of measures of central tendency also, which we must record here, which is the measures of central tendency although they give us one single value for a data set, which is very easy to remember. And we know that this is the value around which all the other values of the data set, they cluster or they're spread around. However, these measures alone cannot describe a data set completely. And we are going to see that with the help of an example here. So we have this data set 1, which is this, and you see these values. And the mean, median, and mode of these data sets, this data set is given as 3.93, 4, and 4 respectively. Now we have another data set 2, which we can see has values which are very different from the values in the above data set. But when we calculate the mean, median, and mode of these data sets, they come out to be exactly the same as which we got for data set 1, 3.933, 4, and 4. So if you closely look at the values contained in this data set, they have different composition, but the measures of central tendency, they come out to be exactly the same. And this is why we cannot use the measures of central tendency alone to describe a data set completely, because they can make you come to wrong conclusions. Such as in this case, if only the measures of central tendency are reported, you may conclude that these data sets are very similar. They're equal or they're very similar, but this is not the case that you have just seen. So for this, we need to have the measures of variance, or which actually record the difference of values of the composition of the data sets also. So which we are going to, in addition to the measures of central tendency, and we're going to have a look at the measures of variance or measures of dispersion. These are the two terms used for those measures. We're going to have a look at them in our next lesson, inshallah.